Hello Math 1 students. So today we're going to do Ready Set Go for section 2.2 module 2 linear and exponential functions. Um, it's a homework section where I have assigned you the homework. For that I'm going to explain few problems from that. First thing is comparing. First kind of questions you will see here in ready part is comparing the rates of change in linear situations. We need to compare the situation. So let's see very first problem. Very first problem is about here the amount of stretch in short bungee cord stretches 6 inches when stretched by a 3-pound weight. That's a short bungee. And then a slinky, there is another one that stretches 3 feet when stretched by a 1-pound weight. We need to figure out which one has the greatest rate of change. So let's see what they're telling us. So they're basically telling us the first case, short bungee. If you're talking about short bungee, it is kind of 3 pounds. If you have 3 pounds there, then it is just 6 inches. But for the slinky, it is having, if you have 1 pound with that, it is going to have just 1 pound. It may not be kind of proportionate, but I just draw it 1 pound, and it's going over 3 feet. But we need to figure out which one is stretching more. So when I look at it, it's comparatively I feel like slinky, but we can have the uh, actual comparison. So if it is 3 pound is stretching 3 feet, can I make it 3 pound? If I'm just changing it to 3 pounds, so how much it will be stretching? It will be stretching 9 feet. So now we have a kind of a comparable situation where 3 pounds on both, the weight on both, but one is having 6 inch, and inches we know it's already um, a, a smaller unit than feet, and 9 feet has, if I talk about, so it's going to be 9 times 12 inches, and it's a lot. So which one is better here? In this case, greatest rate of change, we will say it is going to be slinky. So you have to analyze it and you have to understand how is that going. Okay, now if I move to question number 4, if I try to look at that, riding a bike 10 miles in 1 hour, you are riding 10 miles in 1 hour, and you're jogging 3 miles and in 24 minutes. Okay, so 3 miles in 24 minutes, and here 10 miles in 1 hour. So we can say 1 hour instead of 1 hour, we can say 60 minutes, and you're going over 10 miles. So if you just simply want to think here, there could be different ways how you want to solve your problem. So if I just want to see for riding, what's the rate, like per minute, how much you are riding, that's actually 10 over 60. So you get 1 over 6 miles per minute. Okay, but when you're jogging, when you talk about this scenario, you're going 3 miles in 24 minutes. So if I want to get the speed for that, in that case speed is going to be 3 miles in 24 minutes. So we have this thing, and that's 1/8. All right, 1/8 miles per minute. So when I look at these things, I see which one is going faster. Um, is that going by riding a bike, or this one is the jogging one? You see, this is for jogging. I'm just trying to find out the rate of change, and here it is the bike riding one. So 1/6, is that 1/6 is greater or 1/8? 1/6 is greater. So which one is having a greatest rate of change? We can simply say it's riding a bike. Riding a bike going to be the answer for this one. So you need to compare question number 2 and 3, try on your own and figure out which one is going to be having greatest rate of change. Let's move to the next question. Here what do we have? We have been discrete and continuous relationship. We need to find out. for this one, identify whether the following items best fit with discrete and continuous model. Then determine whether it's a linear, arithmetic, or exponential geometric relationship that is being described. So we can have, like if I talk about question number 5. The freeway construction crew pours 300 feet of concrete in a day. So here we're talking about days, in a day, and we're talking about 300 feet of concrete. Now the feet, it's about concrete, but feet is actually which kind of variable? That's a continuous one. Like you can have decimal for that. All right, and when you think about that, so the relation day is discrete, you can count the day, but the feet is continuous one, so in this case it's going to be continuous. And we see every day it's going to be again increasing by 300. Next day 300 means it starts with 300, 600. You can think like if I talk about number of day and number of feet, how many feet are covered. So here the first day, second day, third day. So first day it was 300, second day it was 600, third day it was 900. I can keep on going. So you see every time it's increasing by 300. So it's an arithmetic sequence. We can say, up to you, you can say arithmetic, linear, whatever you want. Arithmetic, I just choose that to write. Same way, you just look at the other situations and try to figure out what kind of problem is that. If I go to question number 10, at the headwaters of Mississippi River, the water flows at the surface rate of 1.2 miles per hour. So that's the rate how the water is flowing every hour, like per hour, this much miles it goes, it travels this much, 1.2 miles. And when I look at it, I know this change is not happening at once. Like in order to travel 1.2 miles, the water it's flowing gradually. It's not at once. It's not happening at once. It's a gradual process. So again, and another thing you can think about, that we are talking about miles, and miles, it's another way of thinking that miles, it's a distance, and distance is always continuous. So that's going to be continuous. And it's every hour it's changing by 1.2 miles, and so it's just like with the same rate, the constant rate of change. The change is not kind of happening in a different sense. So it's every hour it's increasing by 1.2 miles. So we can say it's an arithmetic. If you want, you can use linear also. Arithmetic or linear, you can use any. Same thing on there, you can use that. Now if I talk about question number for B, when I look at the graph here, I see when your dots are not connected, that's going to be considered as discrete, because you don't have any value in between. It's just changes happening at once, and because it's not a linear, and you see it's decreasing, and in this case it's going to be a geometric, because you don't see a straight line, and it's decreasing by a geometric sequence. So let's move to the next one. Question number 11, 12, 13 and so on. So for this one, note that multiplying 1 over 9 gives the same result as dividing everything by 9. All right, so for this one, when we look at it, we see basically they want to tell you, if you have a number, if you have 90, according to this, if you have 90, if I divide it by 9, what do I get? 10. But if I have 90 and I multiply it by 1 over 9, then again what do I get? I get 10. So multiplying by 1 over 9 or dividing by 9, it means the same. So if I'm multiplying by 5, or I'm multiplying by 1 over 5, or I'm dividing by 5, it is the same thing. All right, so let's move to one of the question here. uh, I would pick question number 13. If we have to solve it, how would we solve it? We need to isolate the variable is x here, that we need to isolate this one. So in order to do that, I have to get rid of 8. It's just like I have to add 8 on both sides. So what do we get? 1x, and we usually don't write 1x, so we just write it x, and that's minus 3 plus 8, that's going to be 5. So that's very easy one and simple one. All right, and we'll move to the next question. Next question, let's try question number 18. Question number 18, we have negative 4 over 7x equal to negative 1. If I have to solve it, how would I solve it? Okay, so very first thing, if you see negative on both sides, so smarter thing is to multiply both sides by negative 1 so that you get rid of negative sign, because both sides have negative. So when you multiply by negative 1 on both sides, it turns out positive. So my question is now easier one. Now if I have to solve this one, there could be two ways to solve it. Let me share how to do that. If I'm going to this one, I'll show you two ways. So first method, if I have to solve it, I multiply both sides by 7 and I get this thing. First method, I get 7 cancels out, 4x equal to 7, and now I divide both sides by 4. I get x equal to 7 over 4. That's my answer. But I personally like cross multiplication. I'll show you another way. Same problem can be done in a different way. If I have 4 over 7x equal to 1, how do we solve it? I can rewrite it as 4x over 7 equal to 1. I can write it like that, like instead of 4 over 7 times x, I can write 4x over 7 equal to 1, and then I can assume this 1 is having 1 as a denominator, because dividing anything by 1 doesn't change the value. After that, I can do a cross multiplication here. So it's a cross multiplication like this. I will be doing it, and I'm going to get 4x times 1 is 4x, and 1 times 7, and then what is it? 4x is 7. Divide both sides by 4, you get x is 7 over 4. Up to you, you can use any strategy. There could be many more strategies to solve the same problem. I hope you get that. Let me solve another question. Let's do question number 14. So that's very easy one. You just divide both sides by 8. 8x is 15. You divide both sides by 8, and you get x is what? 7. That's your answer. Alright, I hope you get it. I explained a question of each kind. Please let me know if you don't get it, and stay safe. Thank you.